80-metre amateur radio band, and also transmitting on the Melbourne television repeater with sound now, VK3RTV, HT, Digital Channel 1, and also streaming on my YouTube channel, VK3CSJ. Just look for the live symbol. Okay, very pleasant good evening to everybody on this 15th of December, as we rapidly come up to the Christmas silly season. And this broadcast is my second last broadcast for the year. I will have a final broadcast next Friday, and then I'll be off for 4 weeks, coming back in the week of the 15th of January when I go back to work, which will be the 19th, of course. All right. Sorry for being a bit late tonight. Just last minute things they're trying to suss out, particularly with the ATV. I couldn't work out why there was no picture coming off the repeater, only to remember that I disconnected the antenna. So I had to quickly fix that up. Anyway, here we are. So, right, we've got a few things tonight. There's also a report from Tamitha Scove. It's a solar report for last week. It basically encapsulates up to, I think, Friday. So it's not really covering this weekend and or anything into next week, but it's looking at what's happened over the last week, let's say, and it's been quite a busy, active sort of a week solar-wise. Anyway, let's get into it and see how we go. We have a Discord chat window also operating too, so if you wish to come up on Discord, look for astronomy chat window, or what's it called? Can't remember. Astronomy chat room. Yes, room. That's the word. And you'll find it there, I guess. We have a few folks there already. G'day, Richard, Martin, and Steve. And I was trying to get my email working. Computer was having some trouble trying to get that running, but I'll get that sussed out in a minute. Email address vk3ekh@gmail.com, vk3ekh@gmail.com. The Astronomical Society of Victoria was founded in 1922, has well over 1,600 members. Membership of the Society is open to all persons with an interest in astronomy. The Society's objectives are to encourage the study and practice of astronomy and to disseminate the knowledge of the science, and to provide greater facilities for the study among its members. Monthly meetings are usually held on the second Wednesday of each month, except in January, where the latter being held on a Saturday night. Meetings start at 8 p.m. at Mollier Hall, Burwood Avenue, Melbourne, near the Melbourne Observatory, and not too far from the Shrine of Remembrance. Parking is available in Burwood Avenue, Dallas Brooks Drive, and the surrounding streets. Admission is free and visitors are most welcome. Privileges of membership include the right to borrow books, periodicals and other publications from the Society's extensive library located at Melbourne Observatory, receipt of the ASV's magazine Crux containing articles, news, observing notes and the like, and the free provision of the Astronomical Yearbook. Access is available to telescopes on members' nights held regularly at the Melbourne Observatory and after monthly meetings, weather permitting. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector. There's also a 200mm refractor managed by the Royal Botanic Gardens, and a recently restored photoheliograph are also housed at the observatory. The Society also has a number of 200mm reflectors available for short period loan in the ASV's telephone loan scheme. Members are also encouraged to make use of the Society's country property located near Heathcote, some 90-minute drive north of Melbourne. There are a range of instruments available for members to use, the larger two with appropriate training, which range from 300mm to 1000mm in aperture. Also located on the site is an 8.5 metre fully steerable radio telescope, which members can access with involvement in the radio astronomy section. Excuse me. Members are encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do the same. Instrument making is only one of the number of common interest activities catered for within the society. Other areas of interest that members can participate in include deep sky observing, astrophotography, lunar and planetary observing, auroral, meteor, comet, radio astronomy, computing, cosmology, astrophysics, historical studies, and research and astronomy in general. In fact, the computing section has been offline, so to speak, for a short while now. It's actually remerged. So the computing section is meeting. I'm not sure. I think it might have been this week, at some stage this week, or possibly even early next week. But it's the first. They're having one meeting, a kickoff, informal kickoff meeting before the end of the year, and just to kick off the computing section. And where did I see that email? There was something that told me about that. Let me see if I can quickly find that. Where is my email sitting? Yes. Just bear with me while I dig up my email client here. And it should be just sitting in here, I think. Mail. It's a new one. I want to run Outlook. There it is. Oh, bright screen. Okay. Now, there was a mail that came through. It was one of these extra emails that ASV put out on a regular sort of basis, and just trying to find that right now. I know it's in here. Here we go. Alrighty then. It's almost time for Christmas. Tonight sees the return. Okay, so it was when was this sent? Sent a few days ago, I think, Wednesday. Okay, so tonight sees the return, Wednesday, computing section, headed by Andrew Hayes. Oh yeah, okay. And Friday they have a busy night with the observatory, with the library, lunar and planetary section meeting. It's tonight. But anyway, they give a bit of a plug here for the computer section. Basically, it says the ASV's computing section is looking forward to you joining us for our Christmas and end of 2023 meeting this Thursday at 7:30 p.m. on Zoom. It's actually Thursday. The ASV's computing section is open to every ASV member, and we would love to have you join us, he says. This last meeting of the year will be a fairly informal evening, and we'll be looking forward to your feedback and suggestions on what you would like to see us doing as we move forward into 2024. All skill levels are welcome. All questions are welcomed. Whatever your flavour is, Windows, Mac, Linux, Unix, Raspberry Pi, ASCOM, Indigo, iOS, Android, please come along. Our adage is we answer the hard questions straight away. The impossible ones take a little bit longer. So that's the computing section for the ASV. It's now kicked off again and going strong by the looks of it. So yes, if you're interested in sitting in on a computing section meeting, there's a email address which you can find on the ASV website under the sections tab, and you can more than welcome to send an email and ask if it's possible for you to sit in. I don't believe you have to be a member, but the idea is that you eventually do become a member if you continue like an interest in it and want to stick to it, sort of thing. So there it is. Yes. Contact details for various section directors are provided in the yearbook, and further information. And if you don't have the yearbook, of course, and actually the newer yearbook has just been released. I received my yearbook just the other day with the latest edition of Crux, and that's downstairs. I should have brought them up. Anyway, Please note that the ASV will conform to all government health directives, and ASV events may be required to be cancelled, moved or postponed. We had the Christmas Star Party last week. I think there was about 120 odd people that rolled up. Unfortunately, the skies didn't give up. It was a cloudy night all night last Saturday, and I wasn't there, but I know that it was a cloudy night, and unfortunately it rained to some degree. So for the folks that headed up to the Dark Sky site hoping to spend a night under the stars, that was unfortunately dashed by bad weather. In fact, if it had been tomorrow, I think it would have been vastly an improvement. I think the weather this weekend is going to be pretty good. That's the way it works out, unfortunately, with astronomy. It's that the weather is very much in control of what you do. Anyway, but it was still successful in its own way. Like I say, there was quite a few people up there, and for the folks that went up there for the first time, they would have been fairly impressed with the site and the way it looks. So there is a high definition all sky cam that's now running, thanks to Lee. So the all sky camera can be accessed via the ASV website under one of the sections, one of the tabs up there. It's got I think it's I'd have to look for it, but it's sitting under one of those links, the top of the page, their homepage on the ASV website, which is www.asv.org.au. Hey you. All right, let's move along now. See if we can finish before 11 o'clock tonight. So says I. In fact, this is my last day for work. I've got 4 weeks off now, thank goodness for that. So I'm looking forward to a nice break from having to rush to work every morning dealing with stupid traffic. Okay, first article, we've got a couple here anyway, and Temethuscove somewhere in there. What happens at the centre of a black hole? Actually, what does happen? No, I think, shall I go to something else first? Depends if this is working for me. Is it still there? Yes, there it is. Okay. Now, just before I go on to that other article, over the last couple of weeks, you might have heard me mention about Betelgeuse partially being eclipsed by an asteroid called Ilona, Betelgeuse, big star, huge star of the constellation Orion. And there was a big deal that a fairly large asteroid was going to go in front of the star Betelgeuse, but that visibility of that occultation of Betelgeuse was a very narrow line across the northern hemisphere. So not all of the world was going to see this. It was just going to be that totality as such, or a partially eclipsed aspect to it at least, was going to be confined to a very narrow strip across the northern hemisphere. There is some video footage that was taken of this, and this is thanks to Marco Lori, somewhere overseas. But let me see if I can just bring, if vMix will allow me to bring this up satisfactorily. Let me just pause this for a second because I don't think it repeats for very long. But for those watching the YouTube channel, and also the RTV repeater at the moment should see a little speck in the middle of the screen. Well, that's the light, a very faint light coming in from Betelgeuse. I haven't played it yet, but what you're seeing there is the light being picked up from a video camera on a telescope looking at Betelgeuse. Now I'll play this video, and what will happen is that you'll see the light twinkle because of the atmospheric effects affecting the stream of light particles, so to speak. But it will dim. It will actually dim as this faint, small. You can't even see the asteroid. But it does eclipse the star Betelgeuse, and the light actually does dip for a moment. So I'll just play this video right now, and as you can see on the screen, it's twinkling, 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 and then all of a sudden the light starts to fade, slowly fades, almost goes away, almost disappear, and then it starts to come back again. Isn't that absolutely amazing footage of an asteroid eclipsing a star, in this case Betelgeuse? It's going to do it again. It's just repeating itself right now. You can see it's dimming, and then it's coming back up again. Really quite amazing. And because, like I say, that was only visible. It's repeating again right now to a very small strip across the northern hemisphere. So the chance to be in the path of that at the right time to see that light dim is pretty good. And of course, mind you, that's how the hunt for EU planets. What's it called? Come back to me. Anyway, there's an article on it in a short moment or two. E-planet, that's not the word. What am I trying to say? Let me open that, and no, I thought I had an article on it, but I don't. Do I? No. Anyway, what's the word? Eco, not eco. E-planets, E something. It's just left me right now. The term they use for finding planets orbiting host stars, and it's exactly the same concept. Watching the light, measuring the very faint line coming from a distant star, and then it dips, and it's you'd have to be in the right position at the right time for that to occur. But if you measure that little dip of light, then the general consensus is that you've found a planet orbiting the host star. E-planets. I forget what it's called. Anyway, but there it is. So it can be done. It is possible to see the light from a distant star drop as either it's a planet, or in this case an asteroid, eclipses in the right time at the right place. So it's pretty amazing grace. All right. Now that I've got my email open, let me just check my emails and see if there's anything sitting in there. We have an email from Mr. Wayne, and we also Mr. Stephen. And 80 metres now operational. Monster signal tonight. Yes. DATV, YouTube, nominal. After a slow start. Yeah, I know. Kick me in the ass. Yeah, that was my fault because I didn't have my antenna connected, so it caused an issue. Always something in the shack. Always something. Anyway, welcome, guys. Any more emails, please send to vk3ekh@gmail.com. Alrighty then, what happens at the centre of a black hole? Courtesy of astronomy.com. And which reminds me, I watched Interstellar for probably the 10th time just the other day. I never get tired of watching that film. Always like the way it's done. And they are thinking of Interstellar 2, a sequel to Interstellar, which Matthew Mahogany will probably also be involved with. Thought I'd mention that. All matter in a black hole is concentrated into a central point of infinite density and infinitesimally small size, or other words, a singularity. The question is, do black holes have centers? If so, what's going on there? Question mark. And there's a little graphic here of a black hole, so I might as well bring that up so you don't have to stare at me all the time. Alright, there it is. And, oh, no, my camera's not on me there. Let me just turn my secondary camera here on me. There it is. So there's an artist's impression of a black hole. And I'm not bending over either. Einstein spent 10 years wrestling with three fundamental concepts in physics: acceleration, the special theory of relativity, and the gravitational force. His heroic effort accumulated in 1915 with the general theory of relativity, an elegant set of equations relating the curvature of space-time to the matter moving around it. Though simple to write down, finding solutions to these equations has intrigued physicists and mathematicians ever since. To tackle any set of equations relating a physical system that evolves with time, a good start is to make assumptions that simplify things. And barely a month after Einstein's publication, a Karl Schwarzschild discovered one of the simplest solutions. His description relating a compact spherically symmetric mass that doesn't change with time to the curvature of space-time surrounding it introduced us to what we now call a black hole. Initially, this solution was dismissed by many because it predicted an unusual situation, that all matter in a black hole is concentrated into a central point of infinite density and infinitesimally small size, a singularity. Singularities make physicists rather uncomfortable. Having established what's at the centre, what about the empty space immediately surrounding the singularity ? Consider the trajectory of a spaceship falling into a black hole. From the point of view of a distant observer, the ship will accelerate and quickly reach the central singularity, but on the way it passes a point of no return, which is the event horizon. The closer to the central mass, the stronger the force of attraction. Inside the event horizon, the force is so strong, equivalently, the space-time is so curved that no engine is powerful enough to overcome gravity and to drive the ship outward. In fact, inside this radius, not even light can move fast enough to escape the attraction of the singularity. Just outside the event horizon, ships will travel on unusual paths, but at least they can return home. The two problems keeping physicists up at night are: one, that our understanding of quantum mechanics makes the idea of a singularity unattainable, and two, the event horizon shields us from measuring what happens inside a black hole. These issues bring us to the cutting edge of theoretical physics, bridging general relativity and the quantum realm, reconciling the event horizons of black holes with the laws of thermodynamics, and even speculating about wormholes, where the centre of a black hole is a pathway rather than a singularity with an unfortunate dead end. We just don't know. Dear, and we'll probably never know. So that was a nice short article, courtesy of astronomy.com. They call it Ask Astro. Alright, you're tuned to ASV Radio, VK3 Echo Kilo Hotel, with the regular Friday night broadcast, the second last broadcast for 2023. Exoplanet. Oh, God. Thanks, Steve. Here I am saying E-planets. E-planets. Exoplanet is what I was trying to say. I'm getting old. Okay. And now, still on the theme of black holes, the biggest black hole merger just got weirder. And here's another illustration, because it's the only thing that we can do. I forgot about that. Okay, so what we're seeing here in the little picture is waves like these could be used as a test for making predictions of merging binary black holes. And the picture is by Mark Myers, which is from the ARC Centre of Excellence for Gravitational Wave Discovery, or OSGRAVE, which I think is an Australian thing, I think. When the LIGO and Virgo observatories detected gravitational waves in the spring of 2019, the event represented the biggest merger of two black holes ever detected. The wave event, called WG190521, shook the cosmos with a power equal to the energy of 8 suns. 8 suns. The signal was brief and lasted less than 1/10 of a second, but by analysing that tiny sliver of time, researchers pieced together that the waves were likely produced by a source 15 billion light years away, when the universe was half its current age, according to an MIT press release. This was especially important because it was the first clear detection of a so-called intermediate mass black hole, a class long hypothesized but not observed until the GW190521 event. This event was the result of two black holes of approximately 85 to 66 solar masses coming together. The result was a black hole with a mass of 142 suns. Despite the merger's power, its frequency was so low that gravitational wave detectors did not pick it up until after the black hole's last two orbits. A new study published last month in Physical Review Letters found that the black hole merger emitted energy as it initially merged and after it wiggled itself into its new shape. The find is the first evidence of waves created by the gigantic black hole as it settled into its new spherical shape. Astronomers are excited by this because waves like these could be used as a test for predicting when the universe was half its current age mergers of binary black holes and their resulting structures. And there's a short video here too which they've made, and let's see if I can play this. It only goes for 19 seconds. I don't know if there's any audio. I hope there's not. There it is. I'll put that on a loop. Okay, so it only goes for 19 seconds. But getting back to this, they say here what you're seeing are space-time ripples from the most massive binary black hole merger ever observed. And is it going to repeat itself? Yes, there it goes. Okay. Black holes want to be spherical. When GW190521 merged, its lopsided shape became spherical after a few milliseconds. The resulting shape change created the waves that researchers detected. By studying the waves, astronomers can deduce characteristics like a black hole's size, mass, and the speed of its spin. The team found that GW190521 produced two signals called ring-down frequencies as they approached. When calculated together, they suggested a resulting black hole of 250 solar masses, even more massive than the LIGO-Virgo team estimated of 142 solar masses suggested in the Physical Review Letters and in the Astrophysical Journal Letters. Results of the study also provided researchers with a way to test and see how well the event supports Einstein's theory of general relativity. And of course, it again proves Einstein right. At the time, I never thought I would ever see such a measurement of my lifetime, says Baradi Krishan, Kirchen, study author and physicist of the Radboud University in the Netherlands, in a statement. So there it is. Another interesting aspect to what happens when black holes merge. Righto, you're tuned to ASV Radio, VK3 Echo Kilo Hotel. Time is 25 minutes to 11. Okay. Something about Enceladus. Enceladus, a moon, one of the moons of Saturn. And we got a picture of that. So I'll bring that up. Where is it? There it is. And I'm still there. Okay, courtesy of astronomy.com. And that last article, by the way, was courtesy of also astronomy.com. New clues merge towards the possible life on Enceladus. Saturn's icy moon offers intriguing chemical possibilities. Seemingly sleepy Enceladus, a moon of Saturn's just a fraction of the size of our own satellite, was barely on the radar of astronomers up until the Cassini mission arrived at the system in 2004. But close flybys in 2005 revealed one of the biggest solar system surprises: plumes of water erupting from underneath the ice shell, likely powered by subsurface ocean. And we do have a picture of that. Where are we? There it is. This is exactly what Cassini photographed. I'll just get rid of me there. So, yes. Plumes, what you're looking at are plumes of water ice, can be seen spraying near the south pole of Enceladus. More than 30 jets of different sizes were captured in this image, taken by the Cassini spacecraft. Flew through the jets on November 21, 2009. So suddenly, Enceladus transformed from an odd, slightly puzzling snowball to one of the most exciting places for astrobiologists. And that's because where there's water on Earth, there's life. But a few other ingredients are also needed to make life, as a new study reveals in Nature Astronomy, though. Enceladus may have them and more. The paper examines data from Cassini and compares data from fly-throughs of Enceladus's plumes to 50 chemical compounds the team suspected might be present in the samples analysed by one of Cassini's instruments, its Ion and Neutral Mass Spectrometer, INMS. The research team then produced models comparing the data and found evidence of detections of a variety of important organic compounds. Searching for compounds in the plume is a bit like putting the pieces of a puzzle back together, says lead author Jonah Peter, in that we look for the right combinations of molecules that reproduce the observed data. Information theory allows us to determine how much detail we can expect from the data without missing important features or overfitting to statistical noise. Water, ammonia, carbon dioxide, and methane had previously been found in an analysis of INMS data, but this study found additional compounds and molecules, including acetylene, propylene, ethane, methanol, molecular oxygen, and hydrogen cyanide. These add to the various hints that Enceladus, despite its frigid perch in the outer solar system, harbours an environment conducive to life deep within its oceans. Hydrogen cyanide, despite its toxic-sounding name, may be one of the most important compounds confirmed with near certainty in the dataset. Peter calls it a key building block for synthesizing more complex compounds related to the origin of life, and says it could be a precursor to some proteins that compose DNA and RNA. But various hydrocarbons are also exciting prospects for life, as they are often a substrate or growth medium for microbial life on Earth, helping to nourish really simple organisms. Other potential detections also excite the researchers. First, there's sulfur. The analysis found evidence of the existence of hydrogen sulfide, which you've certainly smelled before if you've ever whiffed a rotten egg. Hydrogen sulfide hints at geothermal activity within Enceladus, and geothermal events play host to some of the most extreme life forms on Earth that happily thrive among them. The team also potentially detected phosphorus, adding to the evidence of its presence on that moon. Both sulfur and phosphorus are important elements for life on Earth. Sulfur and phosphorus are two elements required for life, along with carbon, hydrogen, nitrogen and oxygen, Peter says. If the existence of sulfur is confirmed, phosphorus was detected at Enceladus earlier this year. This knowledge will help to empower the building of a Enceladus explorer. However, none of these findings yet offer a smoking gun for the existence of life on Enceladus, as all can be produced by non-living means. Peter says laboratory experiments could reveal if these elements and compounds could assemble into a building blocks of life by creating a mini Enceladus. We know that certain amino acids and nuclear bases can form from hydrogen cyanide under Enceladus, like conditions, but what about other biomolecules, he says. Beyond that, a robotic mission might be the next explorative step. Enceladus is too small and remote for even the largest telescopes to determine anything about the existence of life. The present study, even if planetary scientists need to sit tight for a few decades to find any answers, makes Enceladus an even more intriguing possible habitat for microbial life. Yes, a very interesting moon is Enceladus, a very interesting moon indeed. So I do look forward to any attempt to land a probe there. Or should we, on the risk of contaminating its surface? You're tuned to ASV Radio, VK3EKH. Now, let me see, keeping an eye on the time, because I think Tamitha's article goes for about 14 minutes. So I think I might run Tamitha now, and hopefully that'll play okay. So stand by for Tamitha and see how I said the latest in her solar report. I think the audio should come through. I'll just press that.
We have big solar flares, mini solar storms, and some fast solar wind. Those stories and more in the news this week. If you want to learn how weather from our star causes impacts at the Earth that shape the future of our world, join Professors Dr. Jenny Meehan, Michael Cook, and myself as we guide you through a space weather certificate program like no other. To enroll in the Space Weather and Environment Science program offered at Millersville University, go to millersville.edu/SWEN. It's weather for the 21st century. This forecast also sponsored in part by CW Ops. Space weather this week has gotten so busy it's hard to know where to put your eyes. As we take a look at our Earth-facing disk, we were watching this coronal hole expecting some fast solar wind from that and possibly some aurora, but it was a bit of a fizzle since this fast wind didn't ramp up very quickly. Meanwhile, we are looking at this filament here. We've watched it erupt. That was a non-Earth directed solar storm eruption. Now we've been watching this little filament, and on the 6th, it erupts in like a poof. Wait for it. You'll see it right here. Whoosh. Do you see that? And that is a slightly Earth-directed solar storm, but it's mainly going to go north of Earth. Then we were watching this filament over here. But prior to that, region 3513 really woke up and pow, right there, it fires an M2.3 class flare and gave us a bit of a radio blackout in the Western Hemisphere. Then right afterwards, whoosh, do you see that? That's a big filament eruption that's gone east of Earth. So the sun is mainly giving us a lot of eye candy. Speaking of, we had this gorgeous filament eruption. You can see it here in Suvi. Look at that thing. Gosh, that's beautiful. But once again, not Earth-directed. So meanwhile, we've just kind of had a lot of filaments all over the disk, but not a lot of action Earth-wise. So now we turn our sights to coronal holes. You can see this big, long, finger-like coronal hole here. This one is going to be giving us some fast solar wind on around the 10th. It also is going to be met with that one mini solar storm that was going to kind of lead into it. So that could give us a little bit of a push. Plus, we pow, right there, we actually had another mini solar storm launch. So that one is going to be on the heels of this fast solar wind, and that could give us a little bit of an enhancement as well. On top of that, as you see this coronal hole here over in the east limb of the sun, there's also this filament underneath it. This filament erupts, and it actually looks like it's going to elongate this coronal hole, so that causes that to grow a little bit, which may mean even more fast solar wind for us in about a week or so. So there's a lot of stuff going on. On top of that, we had region 3511 wake up, and on the 8th, you can see it right here. Bam! Right there, it fires an M5.5 class flare. This is a big radio blackout. It doesn't last very long, mainly in the Asian Pacific. But since then, it's actually fired off another couple small M-class flares, so we're definitely watching this region for more activity. It's going to keep the risk for radio blackouts high, and also the chances for solar storms high, along with region 3513. And now switching to our M-flare and dayside radio blackout threat meter, you can see the X-ray flux has been sitting around the seafloor over this past week until about the 5th, when region 3513 began to rotate into Earth view. We started rising in X-ray flux as well as solar flux and popping those M-class flares at the R1 level radio blackout. And this has been kind of ongoing until about the 8th, when region 3511 woke up, and bam, you can see that big M5.5 class flare. That solar flare was only a short-lived one, and it looks like we're going to continue to have these little short pops. So don't expect long-duration radio blackouts, but definitely ones at the R2 level are possible over the next few days before this region begins to rotate to the sun's far side, and then things may calm down just a little bit, but the big radio blackouts are not going to be leaving anytime soon, because we have some new regions that are going to rotate into Earth view over the next few days. Switching to our solar storm conditions, we were pretty quiet until, bam, we got hit by that big solar storm on the 1st. You can see it actually bumped us up to G3 levels for a little while. In fact, it gave us some decent storming over the course of the day and gave us some gorgeous aurora over many parts of the world. But then, since then, things kind of quieted down, and we were expecting to get hit by some decent fast solar wind and bump us back up to storm levels. But look at this. All we ended up getting was just a little bit of unsettled to maybe active conditions, and that kind of lasted for a few days, and then things just kind of settled down and got even more quiet. And now we're really sitting at unsettled to quiet conditions. These conditions will likely last until about the 10th, when we get hit by that next bit of fast solar wind from that other coronal hole that's going to be rotating in through the Earth strike zone, and it's going to be sandwiched by those mini solar storms, one ahead of it and one after it. So that could bump us up possibly to active conditions, maybe even storm levels at high latitudes. So aurora photographers, if you're at high latitudes, you definitely could get some more aurora. Aurora photographers at mid latitudes, well, you might need to sit this one out. And during this recent G3 level solar storm that we had back in early December, there were so many aurora photos pouring in, I couldn't keep up with it all. It is very clear that our aurora reporting community has grown by leaps and bounds, and with the camera sensitivities, along with photography skills that are just unparalleled, some of these aurora views have been absolutely mesmerizing. Now, I can't share all of them with you today, but I'll share just some to give you an idea of how many places and how many people saw aurora all over the world, like this gorgeous shot from Norway. An aurora was seen in Scotland. It was also seen in Norfolk in the UK. And it was seen as far south as Mongolia. It was also seen in China and clear down to Japan. And as we travel across to the Western Hemisphere, there were a lot of places that had heavy clouds and a full moon that kind of got in the way, but aurora still managed to poke through that and compete with all of that brightness. And here's a beautiful example in Quebec. An aurora was seen in Manitoba and in Saskatchewan. Amazing colors in Saskatchewan. And as we dip down into the United States, of course, vibrant shows were seen in Alaska, but it also reached New England, and we saw some gorgeous views in Wisconsin. We also saw aurora reach as far south as Nebraska, and it reached as clear far south as Texas. And as we dipped down under, with the beginning of the solar storm, had an explosive display, and all those people down under got the best of it. In fact, there were gorgeous views in New Zealand. It was seen in many places in New Zealand. And it was seen as far north as Perth, Australia. So what else does our sun have in store for us this week? Well, we can no longer use stereo A imagery in order to view the far side of the sun because it's looking at the front side of the sun just like we are. So we have to simulate the far side of the sun using HMI and AIA imagery. And as we take a look at the disk on the simulated far side, you can see we have that big cluster of regions that's transiting the far side right now, especially regions 3492 and 3495. They gave us lots of big solar flares. In fact, they may be launching solar storms on the sun's far side. You can see that big halo that we saw from a big solar storm launch that was far-sighted. That may actually be due to that cluster of regions. Now, meanwhile, as we take a look at our JSOC HMI helioseismology far-sighted viewer, in order to check to see which of these regions are actually surviving their far-sighted passage, we look in the gold region and you can see all the darkness, those dark spots, especially this dark spot that we've got labeled here that's reasonably new. This region is actually two regions, 35, 15, and 16, that have just emerged on the Earth-facing disk. These regions really just emerged only a few days ago, so we're going to be watching them quite closely to see if they're going to be growing quite quickly. On top of that, we also have region 3504, and you wonder, where did 3504 come from? Well, actually, as we take a look at the disk again, you can see we actually are watching region 3504 growing just before it disappears off of the sun's west limb. So this region has actually been going quite quickly and surviving its far-sighted passage. So we're going to be expecting big things from it. You can see it right there. And also regions 3492 and 3495. They've got some really dark patches in the gold regions. So definitely could get some more big solar flares and some big solar storms as these regions rotate back into Earth view, starting here in about 3 to 4 days. Switching to our moon, we are now passing through the third quarter phase on our way to a new moon, with the new moon being on the 13th. So you night sky watchers, if you want to catch those dim objects in the sky, well, now is your perfect chance. And now switching to our solar storm conditions and aurora possibilities over the coming week, we are anticipating the fast solar wind from that coronal hole that's rotating in through the Earth strike zone, and we are expecting that it's going to have a mini solar storm ahead and behind that fast solar wind. So at high latitudes, NOAA is expecting active to minor storm conditions with up to about a 10% chance of a major storm. So aurora photographers, if you're at high latitudes, you definitely could get a bit of a chase here over the 10th through possibly even the 13th before things begin to settle down, and that is good news for you. Now, at mid-latitudes, however, things aren't quite as rosy. We are expecting only unsettled conditions despite the fact that we still have this same kind of thing going on. But here at mid-latitudes, we only have about a 10% chance of a minor storm, and that's going to peak right around the 11th. We might get a little bit of chance for activity over the days prior and after, but only if you're a dedicated aurora photographer should you bother to chase. Now switching to our solar flare and dayside radio blackout outlook over the coming week, we are sitting in the mid 130s right now for solar flux, and this does mean radio propagation on Earth's dayside remains in the good range. The big issue, of course, is that we've got moderate noise on the bands right now, and that is because of regions 3515 and 3511. NOAA is keeping us at about a 40% chance of M-class flares. This is at the R1 to R2 level radio blackout, and about a 10% chance of X-class flares, or maybe a 5 to 10% chance of X-class flares at an R3 level radio blackout. And these levels will probably continue throughout this week, possibly into next week, because we do have those new regions rotating into Earth view, and they are also going to be big flare players, it looks like. So amateur radio operators and emergency responders, expect that radio blackouts at the R1 to R2 level will remain on the menu. Likely not long duration radio blackouts, but enough to kind of be a bit messy for you when you're trying to get some good communications. Now switching to our radiation storm and polar aviation outlook over the coming week, everything continues to be in the green. We are at the D1 normal range for you aviators, and this is at flight level 360, which is also the S0 quiet range for the rest of us. And we do have a slight risk for radiation storms. This is about a 5 to 10% level for an S1 to S2 radiation storm, and that's mainly because of region 3511 that is rotating to the sun's west limb right now. Likely the chances for radiation storms won't really increase all that much. We're keeping an eye on it. But if you're frequent flyers and you're high-risk passengers, and this includes air crew, and you're flying at high latitudes and high altitudes, be sure to check those ICAO advisories often because things could change. But for right now, you're all in the clear. So the space weather this week is being very, very active. We have a ton of things on the sun that's providing a lot of eye candy and a lot of little mini solar storms that are going to the east of the Earth or the west of Earth or even the north of Earth. Sadly, we're not getting any strong Earth-directed solar storms, but we are getting a bit of fast solar wind. So aurora photographers, if you're at high latitudes, you definitely could get a chase starting right around the 10th into the 11th, possibly even into the 13th before things totally quiet down, and then you'll have to wait for maybe another week or so and get another chance. Now, amateur radio operators and emergency responders, well, we've got a couple big active regions in Earth view that we're paying close attention to, and R2 level radio blackouts are on the menu, but likely they're going to be short bursts and not long duration, which definitely helps with radio communications. So just hang in there as these regions continue rotating across the disk. And now you GPS users, well, we don't have any huge solar storms, so that makes GPS reception a little bit better, and these big radio blackouts do seem to be short duration, so as long as you stay away from the dawn and dusk terminators, your GPS reception should be pretty good. I'm Tamitha Skov, the Space Weather Woman. Thank you for watching.
Thank you, Tamitha. It was quite a report covering the week that's just gone, up until yesterday at least. But for us amateurs that do a lot of shortwave monitoring and using for DX work, it's might have answered some of your questions about why the band was either playing up or very good. Anyway, thanks, Timothy. And it's been about 2, maybe even 3 weeks since her last report, so I guess that's why that one there was particularly long. But it's filled in the gap nicely. So what I'll do at this stage is go straight to what Space Weather is currently, spaceweather.com is currently reporting. At the moment, the solar wind is at 436.3 kilometres a second at a density of 3.06 protons per cubic centimetre. The disk of the sun, which looks like this at the moment. It's a very good graphic, that one. Usually it's a bit more high res. It's pretty horrible looking. I must have downloaded it incorrectly. But having said that, there's 1, 2, 3, 4, 5, 6, 7 or 8 sunspots on the sun at the moment. The current sunspot number is 126, and the radio sun, measured at a wavelength of 10.7 centimetres, is currently 155 solar flux units. The aurora over Antarctica is a little... where's my mouse? Is a little high at the moment. If I can just get back to vMix, there it is. Okay, so that's the current view of the aurora australis looking over Antarctica. So there is a slight bulge towards New Zealand, Tasmania as we speak. Probably a very faint glow in the sky from the south coast of Tasmania, I would say. So it's a little bit busy, but not as busy as it's been in recent times. Now the solar flare that occurred just recently, there's a bit of a GIF image of that I can bring up, which is that fella there, and I'll loop that. So the article goes... right, I'll start off at the beginning. Geomagnetic Storm Watch, G1, G3. Minor G1 class geomagnetic storms are possible on the 15th and 16th in response to an incoming solar wind stream with stealthy CME embedded in it. Storm levels could escalate to category G2, which is moderate, or G3, which is strong, on December 17. When the CME from yesterday's X 2.8 class flare arrives. And what we're seeing here is an update. Strongest flare of the current solar cycle. Sunspot 3514 erupted on December 14 at 17:02 UT, producing a strong X 2.8 class solar flare, which I think Timothy pointed to. This is the strongest flare of solar cycle 25 so far, and the most powerful eruption the sun has produced since the great storms of September 2017. NASA's Solar Dynamics Observatory recorded the extreme ultraviolet flash, which you can see happening just there. Radiation from the flare has caused a deep shortwave radio blackout over the Americas, and ham radio operators may have noticed loss of signal at all frequencies below 30 megahertz for more than 30 minutes after the flare. This explosion probably launched a fast-moving coronal mass ejection. Soon after the blast, the US Air Force is reported a Type 2 solar radio burst, which typically comes from the leading edge of a CME. Based on the drift rate of the radio burst, the CME's velocity could exceed 2,100 kilometers a second. And here's another view of that. Here's another view of this explosion from Soho, and I'll loop that. This one it's a confirmation. Newly arriving images from the Solar Heliospheric Observatory showing a lopsided halo CME. So all that matter spewing into space. How's Timothy do it? Whoosh! Although the CME is not squarely aimed at Earth, it does appear to have Earth-directed component. A glancing blow is likely on the 17th of December. Okay, so the KP index is currently 1.33, which is considered quiet. The 24-hour max KP figure will be 2.67, considered quiet. And I think that's about it. As we go down to the cosmic radiation continues to reduce due to the solar radiation. And all right, I think that's about it. Going down the page a bit more. Where are we? Where's our... There it is. And near-Earth asteroids, potentially hazardous asteroids. The current count as of the 15th of December 2023, there are 2,349 potentially hazardous asteroids, with one of those occulting Betelgeuse the other day. Well, maybe not one of them, but anyway, one of them was. So I think that ties the knots on tonight. Yeah. And some of the articles I missed out on tonight, which would have been interesting reading, which I might leave till next week. Intergalactic stream of stars 10 times longer than the Milky Way is the first of its kind ever spotted. I think that would have been an interesting read. While hunting for dark matter, astronomers accidentally discovered the first known stellar stream stretching between galaxies. The trail of stars is also the longest ever seen, and I can quickly show that image for those watching the video side of it. When I say quickly, if I can find it. It's just one of those that I didn't bring across. Images, browse. I know it's just here. There it is. I don't know why I didn't bring it across when I was doing this, but there it is. Oh no, there it is. Oh my God, Clint. Need new glasses. There it is. That stream within that square, red square that you can see there. The intergalactic stellar stream, they call it. Was spotted in galaxy cluster 231 million light years from Earth. Astronomers have accidentally discovered the first known intergalactic trail of stars, the gigantic stellar stream, which is around 10 times longer than the Milky Way, suggests that more of these structures could be lurking in deep space, a new study reveals. Stellar streams are elongated threads of gravitationally intertwined stars that have likely been ripped away from their parent galaxies or nebulas by the gravitational pull of other nearby galaxies. Scientists have mapped dozens of these streams within galaxies, including the Milky Way, but until now, none had been discovered in intergalactic space, meaning the space between galaxies. I'll leave that there. Yeah, very interesting stuff indeed. Very interesting stuff. All right, ladies and gentlemen, I think I'll conclude that for tonight. Thank you very much, Lee, for listening to the second last broadcast for this year. We have our last broadcast next Friday, just before Christmas, and then I'm off for 4 weeks. Come back on the I keep forgetting the date. I think it's the 19th, December, January 19th. That's it, 19th of January. All right, this has been VK3 EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast. We will take a quick listen on the frequency for any stations that might wish to quickly call in and announce themselves. So I'm just getting my pen ready. Okay, this is VK3 EKH listening on 3541. Okay, there's one station I missed. VK3GL, VK7JAH, VK3VIN, VK3SBX, VK3BSC. Who was the other fellow? All right, VK5 Whiskey Alpha, and the other station just then? VK3BCX, was it? Oh, okay. VCL, alrighty. Okay, to the top of the list, Graham in Bunyip, VK3GL, VK3EKH. Thanks, Graham. VK3GL, VK3EKH. Yeah, you're about 30 over tonight, so looks like the short skip is in. Maybe the long skip is in too. Yeah, thanks, Graham, and thanks for that little image there. Lovely and green, isn't it? Some of the colours the Aurora produces is just stunning. Especially some of the photographs where it looks like the aurora is coming straight down right at you from above. I'd love to see that. Oh, maybe one day I'll get a chance to see this aurora. I keep saying that all the time, don't I? Thanks, Graham. Good on you, mate. Let you get back to work, and we'll probably catch up over the weekend some stage. VK7JAH, VK3EKH. Take it away. No worries, Martin. VK7JAH, VK3EKH replying. Very good. Yeah, you're hovering between S9 and 10 over. Fairly clear into Narre South. So band noise isn't too bad tonight. A little bit of lightning crashes just there in the background, but still coming through reasonably well. And yes, I didn't really bother to go out looking for any possible meteor shower. I knew it was on. There was a live stream on YouTube, I think. Might have been Facebook, but somebody had put up a HD camera, a live HD camera, and streaming in real time. And if you look at some of the comments coming from the associated chat on that video, you could see that some people were pretty keen to see if they could catch a meteor through the video stream, and there was a few people making comments like, "Oh, I saw that one. Did you see that one?" Yeah, but it's been a long time since I've gone out and been looking up for meteors. It would be nice to be able to see a meteor shower where the count is pretty high, like a really, really significant meteor shower. I've never seen that. Anyway, but they come around on an annual basis. There's a heap of meteor showers throughout the year. So it's just a matter of being out there at the right time in the morning to the chance of being able to see a few of these. Anyway, all very good. Thanks, Martin. Thanks for the report. And Tamitha always is excellent to listen to. So I'm really good that she does what she does. Okay. Across to you there, Ian. VK3VIN, VK3EKH. Oops, wrong button. There we go.
Here we go. VK3EKH, VK3VIN. And good evening, Clint. Report first up. 5 at 9 plus 30, 30. And you actually touched 40 over 9 on one occasion there, so very good signal tonight. And I could hear Martin down in VK7 at 10 dB over. So all very good. And Tamitha was at her descriptive best. Whoosh!
Whoosh!
Oh dear, just some of the words, they just add to things, don't they? And some of those pictures would have been absolutely absolutely brilliantly graphic from the sound of your description of them. So very good and good articles too, and a good broadcast overall. Nothing much happening here other than the radio and computer and all those sort of things. So that's kept me out of or into mischief. That's about it, mate. Nothing much else. And hopefully I'll be able to listen to the broadcast next week. VK3EKH. VK3VIN. Over.
Yeah, thanks, Ian. VK3VIN, VK3EKH replying. Very good signal from you too. Hovering around the 20 over 9 mark. So, yeah, propagation's good for 80 metres tonight, that's for sure. Yes, I'm always impressed with Tamitha's description there. She gets really excited with the coronial mass ejections. No, I'm glad that I found her little YouTube site that she has. It's been going now for a little while, and I actually found it through the QRZ.com. When you first log in to QRZ.com, there's the page that initializes first is full of advertisements for ham radio one way or another. And one of the inserted images was Tamitha in her space weather. And I thought, that's interesting. Let's have a look at that. And, of course, that's where I found her. So, and subscribed to her channel. So, yeah, excellent stuff. Anyway, thanks, Ian. All the best to you, sir. And look forward to hearing you for the last broadcast next Friday. Across to Steve, VK3SPX, VK3EKH.
VK3EKH, this is VK3SPX. Hi, Clint. Yeah, interesting stuff as usual. I was really fascinated by the black holes. Just amazing, isn't it? The two black holes merging 15 billion light years away, and we get this, very, very brief radio or gravitational wave, from that collision. Just amazing. And I thought too that the two holes suddenly coming together, becoming circular in a few milliseconds, which was a testament to the ridiculously high gravity, of course. But it's just amazing that happens so fast, and it gives rise to the gravitational waves as that happens. Amazing stuff. And Enceladus is an interesting place, isn't it? I hope I'm still around when we send a spacecraft to Enceladus to really explore and see if we can find some form of life there. It does seem to be the best opportunity, although with all that hydrogen cyanide hanging around, I don't think it'd be very good for our type of life. But that's another matter. Yeah, anyway, thanks, Clint. Good stuff. Those Aurora photos are fantastic too. Amazing. All right, we'll see you next week. Thanks very much. VK3EKH, VK3SPX.
Yeah, thanks, Steve. VK3SPX, VK3EKH returning. Yeah, yes to all the above. I really need to make notes of what people say. I'm trying to rely on my tired state. Yes. Anyway, a report on an update on the deck for the dome. I actually had the installation team come out this week, only to get a phone call to say that unfortunately the deck that the dome is to be built on is not flat enough. It's actually out by about 20 millimetres one end. One way, east to west, is okay. It's perfectly flat, but the overall deck has a tilt downwards by about 20 mil. Now, visually by eye, you can't see that. And if the deck was to be used for anything else other than having a scope dome put on it, it would be probably quite okay. But the scope dome's mechanical rotating aspect, there's sensors in the rotating ring, and apparently it's measuring or detecting the level aspect, and it's because the deck is on a slight angle. I've been told that the dome most likely would not function, or certainly wouldn't function very well. So I've been told to, or asked to try and get the deck flattened out a little bit. So I've got the builder fellow coming around on Sunday to work on the deck, and 3.6 by 3.6 metre deck, and try and flatten it out. And the deck's been sitting there now for probably about 10 weeks or so, I guess, and I guess there's been a little bit of earth movement in the ground, I suppose. I don't know. But anyway, hopefully by the end of Sunday or early next week, we'll get that deck corrected, and it will be flat as a tack. And I can report back to the folks at Sidereal Trading that the deck is now flat. Here is a picture of the spirit level with the bubble right dead in the middle, and we'll get the guys back out hopefully as soon as possible to install the dome. So that's the dome update. There it is. Even though you didn't ask, but I thought I'd mention it anyway. All right, I think it's John, VK3 BSE, Bravo Sierra Echo. Take it, VK3 EKH. Yeah, good on you, John. VK3 BSE in Summers, VK3 EKH, Narry Warren South. Very good. Yeah, look, like I say, I wasn't overly keen to be going out, but I guess I'm in the process of building my observatory, and once it gets finally done, and I've got a working telescope in there and camera attached, and something that's that I can go down and play around with, and put a camera up towards the sky and make an attempt to photograph anything that goes over. I'll get more into it. It's like the rolling up at the start of a race. You're all accumulated behind the start line and just waiting for the gun to fire. So I'm a bit like that. I'm just waiting for the gun to fire for me to get stuck into all this astrophotography that I want to do, and taking pictures of the sky and basically looking at the stars through the eyepiece and getting familiar with the sky above. So, wandering out and looking at meteor showers when they are happening, I'll probably get more into that. The last time I think I really was involved with meteor shower was the Leonids back in the early 2000s, I think. And of course, my keenness at the time was to do radio scatter, meteor scatter, which was a buzz because there was quite a bit of activity. There were stations in Queensland, New South Wales, VK5 and Western Australia, VK6 there, all pretty keen to try and work you via meteor. And you can really do it. You've only got in some cases, on average, you've only got a 5-second window to make a contact, but that's the exciting part of it. So I've got that recorded on tape somewhere. I had a reel-to-reel going, and I must try and find where that tape is. Those were the days. Thanks, John. Good to hear you. Thanks for coming up. And okay, on winding the one-to-one bellon too. Dallas, VK5 Whiskey Alpha. You're a good signal when you first called in. Let's see if it's still there. VK3 EKH. Yeah, good on you, Dallas. VK5WA, VK3EKH. That's an interesting observation. I don't think I've heard that one before, but I guess it's a possibility. As they ionize and burn up, the resultant emission, it's pretty high in the sky, though. I mean, yeah, interesting. Yes, not sure quite what to make of that one, but I guess it's a possibility. But you're right, I understand about the attention span side of things. Oh dear, yeah. It's I'm a bit of a night owl. I don't usually get to bed till 2-3 o'clock in the morning, so there's but I'm not very easy to get up early. So I know sometimes with these meteor showers, they say that to get up before sunrise, the best time to look at it is between midnight and the sunrise and all that sort of stuff. So one day. Anyway, thanks, Dallas. You're hovering around 10 over 9 too here in Narre Warren. Thanks, Dallas. There was another station that did call in, but I'll go straight. I think it's Wayne. VK3 VCL, VK3 EKH. Yep, thanks Wayne, good on you. VCL, VK3 VCL, VK3 CSJ, excellent signal from you too, hovering around the 20 over 9, 15 to 20 mark, so mightily good. Yeah, no worries Wayne, and if we don't hear you next week, not a problem. Have a Merry Christmas and all the best for the new year as well. And like I say, I've got 4 weeks off, so we'll probably catch up. My cat has arrived in the shack. There's my pussy cat on the camera for those watching video. Oh, she's a beautiful little puss. She needs to be combed. There's a few little knots there. I can feel that. You see it? You need a comb. Anyway. All right. Cat fur. Now, there was another station that did call in. Try the other station, VK3 EKH listening.
VK3 Bravo Sugar Fox.
All right. That's Peter, I think. Yep. Maybe not. I can't remember. VK3 Bravo Sugar Fox, have a say. VK3 EKH with mental relapse.
No, you're right, Clint. Peter, no worries. It's got nothing to do with old age, of course, so I occasionally get them. Yeah, okay, public gravity waves. I read somewhere that some scientists postulated that gravity travels at the speed of light. And they get a few maths there to back it up, but that's interesting if it does. Okay, on your dome, mate, whoever put it up didn't make it level, eh? Cut once, measure once, or measure twice and cut once.
Yeah.
Practical broadcast, and the solar report went for a while. It was all very bit beyond me, a lot of it, but there's a good on solarham.net. There's a few explanations of the recent activity if you want to have a look at solarham.net. Okay, Clint, all the best. Did you say you were on next week, Dave?
Yep, last broadcast for the year will be next year. Next year. Next Friday. We're going to finish up for 4 weeks. Yeah, no worries. It's Peter or John?
It's Peter.
Yeah, sorry, I don't know why I got that last letter wrong. BSF. I got an E in there instead for some reason. That's what's thrown me. All right, thanks, Peter. Good on you. And yeah, it was a particularly long report, that is for sure. Because normally she averages about 10 minutes. But like I say, it's been about 2 or 3 weeks since her last report, and I guess she was making up for it. Yeah, it is perhaps technical, but no, that's all right. It still sounds interesting. The basic information is, I think, conveyed, and with the emphasis on ham radio and the possibility of us ham radio operators having a bit of a problem trying to be heard across the world. Anyway, yeah, Kiska's a long hair cat, and I normally give her a comb almost daily, but she's as soon as I show her the comb, she sort of starts growling at me, so I've got to work out what to do about that. Anyway, thanks, mate. Good to hear you. Everybody else that's come tonight, thanks very much for calling in tonight. Really appreciate it, and we'll be back next Friday for our last session for 2023. And until then, have a safe week, and stay warm, and and stay safe as well. Jeez. This is VK3 Echo Kilo Hotel for the Astronomical Society of Victoria, concluding transmissions for tonight on 3541, and we'll be back next Friday to do it all again. Cheers, everyone. Yep, thanks, John. All right. Turn that down. Okay, to the folks, what Cat's Fur on me, to everybody watching the YouTube stream, thank you for watching, and we'll be back next Friday to do it all again. There'll be a WIA broadcast on Sunday morning at 9 o'clock on 1825 kilohertz, and then an hour later at 10:30 on the ATV repeater, and then at 8 o'clock Sunday night. And then there'll be the ATV net on Tuesday night at 8 o'clock as well. So with that, this is you've been watching Clint Jeffrey, VK3CSJ, on the microphone for the ASV broadcast. If there's any ASV members watching, a very special, pleasant good evening to you, and thank you for watching as well. So on that note, we shall go to colour bars. Yeah, I think that's all. Joe, VK3BKI, thank you for coming up on Discord, and of course Steve and Martin there as well. And just checking my email one more time. Inbox, Steve, Wayne, no one else. Alright, fine. Okay, cheers everyone, take care, look after yourselves. Bye for now. Actually, I'll go to that instead for a few minutes.